So for this question, I've got the integral and I know what it's equal to, but I need to find one of the limits. So I'm trying to integrate the function like this, and I know it's equal to 211 over 10. So remembering that integration is the opposite of differentiation, if I can work out what a function that I differentiate to is this function here, is this function, and then try and scale it, that will give me what the integral of it is. So I know when I differentiate something, the power decreases. So let's see if I can try or consider the thing in the brackets raised to one higher power than what I've got in my integral. So I'm going to start off with this. Then if I try and differentiate this, I need to use the chain rule. So that will give me 5 lots of whatever is in the brackets. Like that, that's using multiply by the power, decrease the power by 1, and then you need to times it by what the derivative of what's inside the bracket. So in this case, the derivative of 10 minus 2x is minus 2. This gives me a final derivative of minus 10 lots of 10 minus 2x plus 4. Now we can see that this is minus 10 times too big than what I had here. So I need to scale by minus a tenth. I need to scale by minus a tenth. That tells me that the integral that I had, 10 minus 2x raised to the power of 4, is going to be equal to minus a tenth of this thing here. So 10 minus 2x to the 5. And that's between 4 and a. So now that I've done my integration, I can put in the substitution and try and solve this. So I'm going to substitute 4 into this, being really careful using brackets because there's lots of negatives and things being raised by odd powers as such. So when we do that, I'm going to put this in really carefully. Minus a tenth lots of 10 minus 2x all raised to the 5. That x is now 4 raised to the power of 5, sorry, like this, and then I'll subtract, don't forget that extra negative there, 10 minus 2 lots of a all raised to the power of 5, like so, and I know that's equal to 211 over 10. So beginning to simplify and trying to solve this, this bit here, so 2 lots of 4 is 8, 10 minus 8 is 2, 2 lots, so this bit is minus a tenth over 2 raised to the 5, and then being careful with this double negative, it becomes a plus a tenth of 10 minus 2a all raised to the 5, which is 211 over 10. Working this through, because all these terms are divided by 10, I can get rid of them, and 2 to the 5 is 32, so it's minus 32 plus 10 minus 2a to the 5 is equal to 211, because I cancelled all these tenths out. Then adding 32 to both sides, 10 minus 2a raised to the 5 is equal to 243. And now I have to take the fifth root of 243. So the fifth root of 243 is equal to 3. Because it's an odd root, it has to be positive 3, it's not positive or negative 3, so 10 minus 2a is equal to 3. Then solving from there, minus 2a is equal to minus 7, a must be equal to 7 over 2.